Hello everyone, welcome back to my channel. My name is Chandramani Pandey and today we are going to talk about Windows Autopilot. So in this module, we are going to talk about traditional versus modern ways to configure devices, comparison between traditional versus modern ways, what is Windows Autopilot and key technology used in Windows Autopilot, how it works, Windows Autopilot benefits and its requirement, high level process flow as well as user level process flow of Windows Autopilot, Windows Autopilot deployment profiles, and Windows Autopilot deployment scenarios as well as a decision tree. Then we will talk about Autopilot deployment tasks and responsible team, and then we will discuss about enrollment status page and its phases. Now let's start with this module. So before starting the discussion on Windows Autopilot, let's talk about what is the traditional way to configure a device and deploy it. Traditional way of doing device configuration, it starts with building a custom image using System Centered Configuration Manager, also known as SCCM, or Microsoft Deployment Toolkit, or even manual installation of image, and then configure the required setting and capture the ISO. For that, we have to plan for driver upgrades and everything that we need to deploy, like PXE configuration, network settings, configuring IP helpers, etc. And with respect to deployment, we have to plan for user data backup and restored either using USMT or informing users to take their own backups if in case we are refreshing the device. So this is very time consuming and expensive process, and any small configuration changes needs a lot of time and efforts. Now with modern way of configuring the device is very easy and very fast. Vendor has to upload the hardware hash and ship the device directly to the user. Admin has to configure one-time deployment profile and deploy it, and end user just need to power on the device and enter the username and passwords, and the Autopilot service is automatically configuring everything, and in a less than 1 hour system is ready for the production use. So because of time and efforts consumption in traditional way, now organization is moving and adopting modern way of doing device provisioning. Modern ways also allow user to reset their device in case of any issue and reconfigure with same configuration again and again from anywhere in the world. Modern ways also eliminating the need of on-premises connectivity and VPN requirements. Now let's talk about the key comparison between traditional versus modern way of provisioning a device. So with respect to provisioning a device, traditional way is to install the operating system on a bare metal via System Centered Configuration Manager or Microsoft Deployment Toolkit. But with modern way, we can join a device in Azure AD and enroll in Intune, or we can create a provisioning package to join the device in Azure AD and then enroll in Intune, or we can also perform autopilot on a newly purchased device. So with modern ways, we have many ways to provision a device. When we talk about the procurement, we can either purchase bare metal from the vendor and install the operating system as per our requirement, or we can use OEM image or custom factory images. But with modern way, we either need to use OEM images or a custom factory images. In traditional way, Active Directory and NTLM or Kribos authentication is used to provide the identity and authentication. But with modern way, we can use Azure AD or ADFS for authentication. For software update deployment, we can use SCCM or WSUS, which will provide us granular control on each and every update deployment. But with Windows Update for Business, which is a modern way to manage a Windows update, we can configure the device to check the update against Microsoft Update Server and download and install the required update. We can also create ring structure and can defer the update as per our requirement. we can deploy and manage the universal SaaS and Win32 and web apps with traditional ways, but with modern ways, we can deploy all traditional apps plus Windows Update for Business and Win32 apps, which includes multiple binaries. Traditionally, we have to use SCCM to deploy application and configure the device setting, but in modern ways, we can use OMA-DM protocol, which is a lightweighted protocol to configure a device. Traditional way to configure the policy is to deploy the group policy object, but modern way is to use MDM policies, which is using OMA-DM protocol. Traditionally, printer is configured via Active Directory and group policy object, but in modern ways, we can use cloud or internet printing solution. Traditional way to share a file is to use a home drive or folder redirection, but modern way allow us to use SharePoint and OneDrive for business for file sharing. Traditionally, we are using roaming profile, user experience virtualization and group policy to configure user preferences, but we can use enterprise state roaming O65 start menu layout via MDM configure the user preferences. Traditional way to manage the access control is to use Kerberos authentication, NAP or direct access or VPN. But in modern way, we can use conditional access and multi-factor authentication to manage the access control. Now let's discuss about what is Windows Autopilot. So Windows Autopilot is a collection of technologies used to set up and pre-configure new devices and getting them ready for productive use. Windows Autopilot can be used to deploy Windows PC as well as HoloLens 2 devices. Windows Autopilot is used to configure a supported version of Windows 10 or 11 for productive use. Autopilot is only possible when we have operating system installed on the hardware, meaning Autopilot is used to configure the operating system and not to install the operating system. To install the operating system, we have to use either SCCM or MDT or even USB stick. We can also use Windows Autopilot to reset, repurpose and recover devices. Windows Autopilot is an easy and simple way to achieve this. Now let's discuss about key technologies used in Windows Autopilot. So Windows Autopilot is mainly using 4 components. The first one is Windows Autopilot Deployment Service. So Windows Autopilot Deployment Service is responsible to check the device is registered in Autopilot service, and if yes, then configure the device as per deployment profile configuration. The second component is Azure Active Directory. So Windows Autopilot requires the device to be Azure joined or hybrid Azure joined. This is used for the authentication and authorization, as well as when OEM register the device in Autopilot, then device object will be created in Azure AD and all the deployment will be targeted to the device object. The third component is Office 365, which is used for license management and adding custom domain. The fourth and very important is Microsoft Intune console or services, which is used for creating deployment profile, assigning the deployment profile, configuring enrollment status page, creating applications, creating profiles and policies for deployment during Autopilot. So with Windows Autopilot, there is no need to reimage or manually set up new devices before handover to user. Hardware vendor can directly ship the device to employee with 3 simple steps. The first step is device registration, in which the hardware vendor adding the new device to the Windows Autopilot deployment services by uploading the hardware hash. In second step, admin is creating the deployment profiles and assigning the profiles to the device in Intune portal. And last step is to ship the device, in which vendor will ship the device directly to the user. User have to turn on the device, go online, and Windows Autopilot delivers all the application and setting. Now let's talk about the Windows Autopilot benefit. The very first benefit is no maintenance of images and drivers. So with Autopilot, we no need to manage the images, as well as there is no need to manage the driver. Once the machine is fully configured via Windows update ring, machine is going to receive the required drivers from their respective vendors. The second advantage or benefit is for the IT department. They no need to touch the devices, because the device are directly shipped to the end user. The IT support is only limited to autopilot troubleshooting related stuff. The third advantage is reset the device back to business ready state. With autopilot, we can remove the personal files, apps and settings. We can reset the device from the lock screen anytime and apply the original settings via autopilot reset, and device are returned to fully configured, also known as approved state of IT approved state. The fourth advantage is the integration in the device supply chain. We know that the very first step in Windows Autopilot is to enroll or register device in Autopilot service. So OME distributors and resellers make this process very easy. They automatically add the devices in Azure tenant at the time of shipment. They can associate the device to customer purchase order for easy device grouping. They can tag device with customer specific labels, as well as they can provide a pre-installed image that is ready for the configuration. The last and the most important benefit with respect to user just need to provide the email ID and password to configure the system, no matter whether user is on internet or intranet. Now let's talk about the Windows Autopilot requirement. So with respect to Windows Autopilot requirement, we can divide into four types. The very first one is the software requirement. The second one is network requirement. Third one is related to licensing, and fourth one is related to the configuration requirement. So with respect to software requirement, Autopilot can be performed on Windows 11 or Windows 11, Windows 10, as well as HoloLens PC. And there are some specific edition on which we can perform the Autopilot. So with respect to Windows 11 supported edition, we can perform Autopilot on Pro Education, Pro for Workstation Enterprise, and Pro Education edition of Windows 11. With respect to HoloLens edition, Autopilot for Windows HoloLens 2 required Windows holographic version 2004 or later, and for Windows 10 the supported editions are Windows 10 Pro, Windows 10 Pro Education, Windows 10 Pro for Workstation, Windows 10 Enterprise, and Windows 10 Education. So with respect to network requirement, Windows Autopilot depends on a variety of internet-based services, and access to these services must be provided for Autopilot to function properly. Ensure DNS name services, name resolution for internet DNS is working, allow access to all the hosts via port 80 and 443 and 123 should be configured. Additionally, we may require to grant access to the required services in the environment that have more restrictive internet access and require authentication before internet access can be obtained. So with respect to this, we have many services, and for each services there are some URLs required. So to access the Windows Autopilot deployment service, there are some URLs. We need to whitelist those URLs from on premises so that we can perform the autopilot smoothly. So if you want to perform the if you want to activate the Windows 10, then we need to whitelist some of the Windows activation URL. Similarly, if you want to authenticate the authenticate the user during autopilot, then we need to whitelist the URL related to Active Directory. Similarly, for Windows Microsoft Intune, Windows Update for managing the update, if you want to manage the delivery customization, we need to whitelist some of the URLs related to delivery optimization. Similarly, for network time protocol synchronization, domain naming service, diagnostic data network connection status indicator, and then Windows notification services, Microstore and Microsoft for business and education, Microsoft 365 certificate revocation list, hybrid Azure AD join, as well as the Autopilot self-driven mode for Autopilot and pre-provisioning. So these all services and their respective URL should be whitelisted when we are performing Autopilot in on-premises environment. And then third requirement is related to licensing. So when we are performing the Autopilot, we should have a supported license, and these Autopilot services is included in the following Autopilot licensing scheme, which includes Microsoft 365 Business Premium subscription, Microsoft 365 F1 or F3 subscription, Microsoft 365 Academic A1, A3 or A5 subscription, Microsoft 365 Enterprise E3, E5 subscription, Enterprise Mobility Plus a Security E3 or E5 subscription, which includes all needed Azure AD and Intune features, Intune for Education subscription, Azure Active Directory P1 or P2 subscription, and Intune subscription as an alternative MDM services, and Windows 10 1709 or higher specific capabilities may require higher version as well. With respect to configuration, there are some configuration which is one-time activity and some are optional as well. Like configuring Azure Active Directory automatic enrollment is a one-time activity and which is mandatory to enroll the device automatically in Intune. The configuring Azure Active Directory custom domain is required when we do not want to use Microsoft predefined on .microsoft.com domain name. Azure Active Directory join permission is required to join the device in Azure AD. Device should be registered either via hardware vendor or we can manually upload the hardware hash. We need to create a deployment profiles and optionally automatically set up from Windows Pro to Enterprise Education. If you want to upgrade your all Windows 10 Pro edition to Enterprise Edition, we need to create a deployment profile for that. If you want to create enable the subscription, we can do that, or even if you want to perform Autopilot in a hybrid edition scenario, then we need to configure the ODJ connector. Now let's discuss about the Windows Autopilot high level process flow. So this is a 1000 feet overview of Windows Autopilot process. So we know that in an Autopilot process, we have mainly three key players involved. The very first one is the hardware vendor, who is uploading the hardware hash in Windows Autopilot services either via OEM APIs or via Partner Center portal, and then they are going to ship the device directly to the end user. The second key player is the IT administrator or the Intune administrator, who is going to configure the Autopilot deployment profile in Intune console. And the third one is the employee or the end user, who is going to perform the Autopilot. So when the hardware hash is uploaded by the hardware vendor, those hash are synced between Windows Autopilot services and Intune. So once the synchronization is done, all the deployment configuration profile, whatever we created in Intune, is targeted to that hardware hash. And then once the user is performing the Autopilot, then the very first step to check against the Windows Autopilot service whether the machine is an Autopilot machine or not. If Windows Autopilot service is detecting that this machine is on Autopilot service, they are going to provide the deployment profile, and the machine is going to download that deployment profile and configure the out-of-box experience as per the configuration. At the same time, machine is also going to check if there is any 0-day vulnerability or Autopilot update available for that device. If machine is detecting that there is an 0-day or Autopilot available, the machine is downloading those things and installing those updates accordingly. And if we configure the device name in the deployment profile, machine is going to configure the device name accordingly, and then machine is going to reboot it. So once the machine is back and online, user is on onboarding page where they need to provide their Azure AD credentials. Once they are providing these, machine is going to join in the Azure AD and enroll in Intune, because we already enable the automatic enrollment in Intune. So once the machine is enrolled in Intune, then all the device based and user based policies are deployed on that device and installed during the ESP page, and deployments are completed, then user can log in with their Azure AD credentials and they are ready to use their machine. Now let's check what is the end user experience when they are going to perform the autopilot. Now consider a scenario where user is now performing an autopilot and they are currently on out of box experience window. The very first window they are going to get during out of box experience is the region window, where they have to select the region as per their requirement, and then they will get a second window where they need to select the language, and the third window is the keyboard layout, where user need to configure the primary as well as secondary keyboard layout. So these are the three windows which we cannot customize during autopilot, and after that we can customize many things. So now once this user is already configured their keyboard layout, then machine is going to check whether the machine is having an internet access or not. So if user is already on hardwire or using a Ethernet cable, then we will not get this Wi-Fi window. Otherwise we'll get a Wi-Fi window where we need to provide the username and password so that we can get the internet access. Once this step is done, then machine is going to check against the autopilot services and see if there is if this machine is an autopilot machine. And if this machine is an autopilot machine is going to download the deployment profile and configure the out of box experience as per the configuration and deployment profile. So once the out of box experience window is configured, user will get a similar kind of window. So this is a Azure AD onboarding screen where they can verify that they are connected with the correct domain. Okay, and they need to provide their user name and password in this window, and once they are going to provide this, machine is going to join in Azure AD and enroll in Intune. Once the machine is enrolled in Intune and we already deployed all the deployments related to device as well as user from Intune, you will see this enrollment status page screen where they can track down the deployment with respect to user deployment as well as the account deployment. Once the enrollment status page is completed, now user can log into the Windows using their already credentials and they can start their work. Now in the previous slide we already talked about what screen user will able to see while performing the autopilot. But now let's talk about what all they are not able to see or the backend process involved in the autopilot. So we know that when the user is on out of box experience window and going to perform the autopilot, they have to configure the language, they need to configure the region, and they need to configure the keyboard layout. Optionally they can configure the secondary keyboard layout. And if the user is already using Ethernet cable for internet access, then they will not be prompted to provide their Wi-Fi password and credentials for accessing the internet. Now after this, once the machine is having internet access, machine is going to check against the Windows Autopilot and see if there is an autopilot profile or autopilot profile deployed on the device or not. If the machine is an autopilot machine, in Windows, machine is going to download the autopilot profile. At the same time, machine is also going to download the 0-day patch, as well as if there is any autopilot update available for that machine is also going to download that update. Okay, and machine is going to install those updates and then configure the out of box experience as per the deployment profile configuration. If we already configured the specific naming convention in the deployment profile, then machine is going to rename the device accordingly, and then machine is going for a reboot. So once the machine is back and online, they will again check whether the internet connectivity is there or not. If you already configured the license agreement in our deployment profile, then user will not able to see this ULAX license agreement page. Then they are directly landing to this Azure Active Directory onboarding page where they have to provide the username and password. Once they are providing the username and password, machine is going to join in Azure AD and enroll in Intune. Once the machine is enrolled in Intune, then user is directly moving to this enrollment status page where they can track all the deployment related to device base as well as the user base. Once this is done, user can log into their in their Windows using their Azure Active Directory password, username and password. Now let's talk about the Windows Autopilot deployment profile. So Windows Autopilot deployment profile are used to configure the Autopilot devices. It's like an answer file, and by reading the answer file mentioned in the profile, Intune is configuring the out-of-box experience in screen. We can create up to 350 profiles per tenant. Now let's talk about the different types of deployment profile. So we have three types of deployment profile. These are user-driven Azure joined, user-driven hybrid joined, and the self-deploying Azure joined. So in case of user-driven Azure join, machine is joined to the Azure and then enroll in MDM solution. In case of user-driven hybrid join, machine is joined to the on-premises AD and then registered in Azure and then enroll in Intune. And in case of self-deploying Azure joined, machine is joined to the Azure and then enroll in Intune. So to create a deployment profile, we have to go to Intune portal and then under Windows Enrollment blade, we need to go to the deployment profile and then we can create a deployment profile. So in the out-of-box experience window, we can either configure a user-driven or a self-driven deployment profile, and then configure as either we need to go for hybrid join or an Azure join profile, and then we can configure the Microsoft Windows license term and agreement, and then privacy setting, hide the account options, and then user account type, whether we want to create a administrative user or a standard user. Do we want to enable the white glove, or what is the language, and automatically configure the keyboard based on the OS language, and then apply the device naming convention. Now let's talk about the Windows Autopilot scenario. So each and every organization is different with respect to their nature of work, so their requirement is also different. Windows Autopilot is fulfilling and catering all these different types of requirement. There will be 4 to 5 scenarios where we can use Windows Autopilot. These are Windows Autopilot user-driven mode, Windows Autopilot self-deploying mode, Windows Autopilot reset, pre-provisioning also known as white glove, and last Windows Autopilot for existing devices. Now let's check the different types of deployment scenario, and in each scenario what option we can use. So the very first scenario is that when we want to deploy and configure a device so that end user can set it up by themselves. So in this scenario, we can use a Windows Autopilot self-driven mode where user can perform the autopilot by their own. The second scenario is where we want to deploy and configure the device automatically. Basically, the device could be a shared device, kiosk, or digitally signage device. So in that case, we can use Windows Autopilot self-driven mode. The third scenario is where we want to redeploy a device in a business ready state. In that case, we can use Windows Autopilot reset option. The fourth step is to pre-provision a device with up-to-date application policy settings. In that case, we can use pre-provisioning, also known as white glove. The last scenario is that where we want to deploy Windows 10 or 11 on an existing Windows 7 or 8.1 devices. In that case, we can use Windows Autopilot for existing devices. We can also take the decision based on the device type and then create an autopilot deployment profile accordingly. So device could be a kiosk device, digitally signed device, HoloLens device, or a typical standard device. If a device is a kiosk or a digital signed device, then we can create a self-deploying Azure deployment type in which the autopilot is going to configure everything without user interaction, and then machine is going to join in the Azure and enroll in Intune. If the machine is a HoloLens machine, then we can use self-deploying Azure AD deployment type. In that case, again, the machine is going to join in Azure AD and enroll in Intune. In case of typical standard devices, we have two options. We can either use a user-driven Azure AD deployment type, or we can use user-driven hybrid Azure AD deployment type. In case of hybrid Azure AD deployment type, machine is going to join on-premises domain registered in Azure AD and then enroll in Intune. Now let's discuss about the Windows Autopilot deployment related task and the responsibility. So by this time we know that there are mainly three players involved in the Autopilot deployment. The very first one is the OEM or vendor, the second one is the Intune administrator, and then third one is the end user. So each player is having their different tasks and responsibilities, and they are going to when we are talking about the Autopilot. So with respect to vendor task, vendor is going to register the device in Autopilot services by uploading the hardware hash, and then they are going to ship the device directly to the user. With respect to end user task, end user needs to perform the Autopilot. They need to provide the username and password, and then they're good to go with the Autopilot process. The main and important task is related to the Intune administrator task, in which there are some configuration which they need to configure in the Azure Active Directory, like configure the automatic MDM enrollment, which allows to automatically enroll the device in Intune. Then they have to configure the company banding so that user can ensure that they are connected to the right domain. They need to ensure that user can join the device in Azure AD by allowing all the user to join the device in Azure AD. There are some tasks as an admin, Intune admin, we have to perform in Intune portal. The very first one is to ensure and enable the enrollment status page. The second one is to ensure user can enroll the device in Intune. And third one is to configure the offline domain join connector if in case we want to perform, we are going to perform the hybrid Azure AD join deployment type. We need to create a dynamic group, device group, and they have to create a deployment profile, then deploy this deployment profile and deploy the required application configuration and policies. Now let's discuss about the enrollment status page. So enrollment status page is very important page in Windows Autopilot, which displays the provisioning status to people who is enrolling the Windows device as well as signing in for the first time. We can configure the enrollment status page to block device use until all required policies and applications are installed on the device. Device user can look at the ESP to track how far along their device is in the step process. The ESP can be deployed during the default out-of-box experience for Azure Active Directory joined device as well as Windows Autopilot provisioning scenarios. To deploy the ESP to devices, we have to create an enrollment status page profile in Microsoft Intune. Within the profile, we can configure the enrollment status page settings that controls what we want. Show the profile mode, set time limitation, error handling and user information, show out-of-box experience to first and every new users, block device until all selected applications and configuration profiles are installed. So ESP use the enrollment status tracking configuration service provider, also known as CSP, and the first sync status CSP to track the application installation. There are three phases in enrollment status page, and these phases are device preparation, device setup, and account setup. Device preparation is mainly used to secure the hardware, joining the device in organization and register the device in MDM server. Device and account setup phase are showing the security policies, certificate profiles, network connection, application deployed on devices and user respectively. In device preparation, the very first step is to ensure or secure the hardware. To ensure that device completes the trusted platform module, key attestation and validates its identity with Azure AD. Azure AD sends a token to the device which is used during Azure AD join. The second step is to join the device in organization, and the third one is to register the device in mobile device management. With the help of this step, machine is going to enroll in Intune. During device setup phase, we can track the security policies, certificate profiles, network and application, whatever we deployed on the device. After that, within account setup phase, we will track the security policies, certificates, network connection and application deployed on the user. I hope this is an informative video for you. Thank you very much for watching this video.